Hey, this is Mr. J here. Let's go through this inverse trig lesson. All right, to start out with, inverse means that the x and y values are going to swap. That's the basic principle sitting behind inverse functions. There are many, many different types of inverse functions that you'll learn about, in the coming years of math. All right, but the first thing we want to understand is that the inverse is given by this little symbol here that looks kind of like a -1 exponent, but it's really not. It's just simply the symbol for inverse. Okay, so that's what that means. So over here you've got regular sign, where you've got the angle that's going in, and you've got the ratio coming out. We know that it's the opposite of a hypotenuse. Looks kind of like an equation. You'll learn in a couple years that there's actually going to be a graph sitting behind this. We know then that we come over here and we compare that to the inverse, and look what happens. Again, like I said just a moment ago, that the angle is going in here in regular trig, but it comes out. It becomes the output of inverse sine, okay? And likewise over here, the ratio which comes out of regular trig, it becomes the input into inverse trig. So if you know the lengths of two sides as part of a right triangle, you should be able to choose the right inverse trig function in order to be able to figure out what the angle is for the particular angle that we're trying to find. So in this case right here, it looks like in this triangle, we're trying to find angle A. All right, well, let's just do our normal thing and set up our letters for opposite, adjacent, and hypotenuse. Always like to find the hypotenuse first. Always like to do the adjacent, remember, because those are always going to be the two sides that form the actual angle that we're talking about, and so there's the opposite. So just like we did when we were solving for sides, okay, we can't use inverse sine here because we don't know what the opposite is. But it looks like since we know the adjacent and the hypotenuse, then we can use inverse cosine. So let's set that up. So inverse cosine, all right, here we go. It is going to take the ratio of the adjacent side over the hypotenuse in, which in this case is going to be 12 over 13, and it's going to give us angle theta, or A, back. Okay, so now that we have the calculator up here, and let's do the inverse. Remember, you got to go under function here. Let's find the inverse, and let's do 12 divided by 13, and boom, right there it is, 22.6 degrees. Okay, we're back over here on the whiteboard, and we know that angle A is 22.6 degrees. Well, how do we find angle B? Well, that's easy. Angle B is simply going to be 90 minus 22.6, which gives us 77.4 degrees, right? So that's 22.6 degrees, and that angle is 77.4 degrees.